Good morning, class. Remember yesterday when we talked about the water cycle?
Yes!
Okay, well, today, before we get started inside, we're gonna go on a little walk and see if we can see water cycle aspects anywhere around us.
Ooh.
Okay, follow me. Now let's remember to look at the ground and things above, because there might be stuff on trees. Do you see this? It looks like there might have been a puddle there before. Why do you think it's not there anymore? But look at that. It's a puddle. Why is that one not dried up? Looks pretty deep to me.
Whoa.
Let's see if we can find the water cycle anywhere else. Come look at this. You might have to get really low, but you can see little drops of water collecting on these pieces of grass. Do you think the water is doing something beneficial for the grass? Do you see this? This leaf looks like it's wet. It must have rained or something. So, as we can see, there's so many aspects of the water cycle around us all the time that we just haven't noticed. So, remember yesterday when we did that little experiment with the 2 cups? We are going to go back inside and take a look at it because there is something really important about the water cycle that we are going to find out with that cup experiment. Let's go.
Yay!
So does everybody remember last week in class when we filled up the clean cup and the dirty cup?
Yeah.
Does anyone remember what we predicted would happen? Does anyone have any predictions of what they thought would happen before I show you what happened to the cups? Yes?
It gets dirtier.
That's an interesting prediction. Yes?
They go the same. They end up being the same.
What do you mean by they go, what is the same? Does anyone want to clarify what Grace was saying? With the cups being the same?
They remain at the same level.
The water,
the same
yeah.
water level.
So we predicted that the water was going to stay the same because they started with the same amount. But, look at these cups and can you tell me what you see? Grace?
The clean cup went down.
Does anyone raise your hand if you agree with Grace? Does anyone have any guesses for why they think the dirty cup stayed fuller than the clean cup? Yes?
Maybe the dirty particles cause it to be heavier, making the water level rise.
That's a very interesting thought for a grade 3. You're very smart. Yes, Grace?
I think the gross stuff came alive and they're swimming around in there.
Maybe, that would be cool.
I think maybe the dirty stuff created a seal on top so that it didn't absorb, evaporate as quick as clean water.
Oh, that's an interesting word you used there, Miss Louisa.
Why, Miss Jacqueline?
We're going to be talking about evaporation today.
I
So,
read the textbook.
it's true that dirty water always evaporates slower than clean water. So when we're thinking of when we went on our nature walk, which we already did, and all the times we're in nature, how could this be applied to when we're outside in real water situations? What do you think? Yes?
The rain?
The rain, yes, but do you think when there's water pollution outside, this could maybe affect whether, is our water becoming cleaner or dirtier outside?
Dirtier.
Dirtier? So what do you think might be the problem if all our water is dirty and evaporating slower, then what do you think that's going to do to our water cycle?
An overflow?
Introducing prediction. Does anyone have anything else?
Tsunami?
Tsunami. Does anyone have anything?
We're not going to have enough clean water to drink.
A clog.
That's true. A clog. It could mean that our water cycle is moving at a much slower rate, which means that we won't have as much clean water at the same time, which will be a problem. we're now going to do an experiment with Miss Kenzie.
Oh goodness.
So remember, you can add to flip your page and add to your model about what you have thought about clean and dirty water evaporation.
Okay, so before we start with our kettle experiment, you guys are going to add to your model and write what you think is happening to the water when the kettle's not turned on and it's not heating up. So I'll give you a couple minutes to add what you think is...
Are we allowed to talk with our peers?
Yes, you can talk with your group, your table groups, and write down.
But first think.
Yeah.
Think, then pair, then share.
So I'll give you a couple minutes.
I like blue water.
Well, what do you think's happening to that blue water? The water is just blue so that we could see what is going to happen more clearly.
I think it's staying the same. Nothing's happening.
Yeah.
I think it's clean water, so it's gonna go faster.
Do we think the water is moving at all? Do we think it's moving slower than what it will when we turn it on? Do we think it's faster?
I think it's gonna speed up.
Do you think any evaporation is happening right now with not cold water?
Not yet.
What about if I open the lid?
Yes, with the lid up, yes.
I'm unsure.
Well, we're gonna find out.
There's no evaporation at all.
Right. Well, when we look back at our cups, this wasn't heated up, and did it still evaporate?
Yes.
Does it?
But I don't know if the lid has any effect on the evaporation or not.
I think it does because it's a bigger hole.
It's just giving the evaporation somewhere to escape.
Except more room, no?
It's giving the water droplets room to leave, but I don't know. Write it down.
So like 2 minutes later, I'm just gonna pretend that.
2 minutes later.
Okay, so now I'm gonna pass out your guys' observation sheet. We've already used this before with other experiments, so you guys know how to use this already. So I'm gonna each give you guys your own. You'll be writing your own ideas on your sheet. You can ask each other questions and use their ideas, but everyone writes their own sheet. So what we're gonna do is the hypothesis part. We've already done this before, so we know what that means. We're gonna guess what we think is gonna happen when we turn the kettle on. So what we think is gonna happen to the water based off of what we know about the clean and dirty water cups.
Also, the food coloring did not make the water that much dirtier, so it won't be the same as the
Yeah,
dirty
the
water.
point of the blue water is so that we can clearly see where it measures on the kettle. When you're done writing, give me a thumbs up so I know you're ready to move on to the next thing.
Would anybody like to share their hypothesis? Grace?
I think the water will go down, evapo something, faster when it is hot.
Why do you think it will be faster when it's hot?
I think the heat will make it go down faster.
Does anyone want to give a guess on why they think the water would go down faster?
I think there's gonna be gas that comes out.
Interesting.
Bubbles.
I think it's gonna be forced out from UV bubbles.
Yeah, because have you seen a kettle get heated up before?
Mm-hmm.
Okay.
Okay, so now I'm gonna turn the kettle on and I want you guys to pay attention to what you hear. What do you see is happening to the water? So is it moving? Is it staying the same? Does the water look the same? And then what do we think is happening? Sorry. So I'm gonna turn it on and we're all gonna look and we're gonna stay quiet and not speak so everyone can hear and listen to what is happening.
Can everyone see what the measurement is? Maybe write down how much does it start?
0.50 L.
Anyone know what the
Got that,
L stands
Alyssa?
for?
0.50.
No, I don't know what it means.
Does anybody know what the L stands for? Stands for liters.
I see.
I drank a liter of Coke before
A whole liter?
by myself,
And if you flip it around,
Who told you to do that? Dad?
brother.
1 liter.
That one says 2 cups.
Yep. So we could
Write that down.
1
2
liter
cups.
or 2 cups.
Half a liter.
Wow.
Good catch, Grace.
Yeah.
She's smart. She should sip aside for everything.
Does anyone?
Oh.
Guys, it's getting foggy.
Oh, it is getting foggy. You're so smart,
Look at-
Grace.
You can hear a little popping.
What do you think the kettle is doing to the water?
Making it hot.
Heating it up. Stuff coming out of the top.
Yeah. Want to touch it? Be careful, it might be kind of warm.
Lawsuit.
What do you think will happen if I open the lid?
No idea.
It might explode. Can you hear the bubbles more clearly?
It's just air.
It's hot air.
Yeah.
Smoke is. We're going to really interesting add to the water cycle. We haven't got into perspiration yet.
So, before we talk about what's going to happen, you guys can share with your table group what you wrote down on your observation sheet. Bing bubbles and maybe noises that sounded like the wind. It went shh.
Yeah, I wrote hushing sounds like.
Soothing sound, yes.
I
I
wrote,
saw fogging happening around the
Foggy, definitely
glass.
foggy.
I wrote water dripping from the sides.
Oh, smart. I said bubbles and then I quickly changed it to bigger bubbles.
Yeah. I said little bubbles, and then I was going to change it. I also thought the little bubbles were stuck to the ground at first. They were all just forming on the ground.
And then they went up.
Then they went
Then they
up,
rose.
way up.
I think it made hot water.
Interesting. And did you notice anything comparing the hot water to the cold water? About the evaporation?
And now there's
What's it at
evaporation all
now?
over.
Let's check what it's at now.
Yeah.
0.50. It's the same.
It's under 0.50 now. It went this much lower because Because it's all on the sides now.
And out the top in the air, right there.
So do we think
Wow.
this maybe is the water coming out?
Yeah.
Coming out in a different form.
Good point.
Ooh,
Different.
that's an interesting thought, Alyssa.
So now I'm gonna give you guys a couple minutes to add to your model now what you think is happening. So adding what you already did before.
Okay, so now that we've talked in our group and written our observations down, what did you notice from this experiment with the kettle to our nature walk outside? Were there some similarities you saw outside? Did you see, or what was different?
It was different because it wasn't boiling water.
Yeah.
All the water was on the ground or in the sky.
And it might have been cold water.
Mm-hmm. Did we just see evaporation outside, or did we see some other parts of the water cycle as well? Did we see some rain outside? Did we see puddles outside?
Yeah.
So what did you notice, going back to the kettle, what did you notice happened to the water in the kettle over time?
It got lower.
It got lower.
The bubbles got bigger.
The bubbles got bigger. What else did you notice?
It started sounding louder.
It made a sound. What kind of sound was it?
Like a waves.
Made a wave sound. Okay.
The kettle got foggy. It has little bubbles on the side now.
It got foggy. And there's bubbles on the side.
Mm-hmm.
Smoke was coming out the top.
Smoke. Was it a lot of smoke or a little bit of smoke?
A little bit.
A little bit of smoke. Did it look any different when we took the lid off?
When
More smoke came out.
More smoke came out with the lid off. So bad. What do you think happened with the water? Do you think that it disappeared, or do you think it did something else when it went up? If there's less water in here now, do you think that when the water went up, it just disappeared, or do you think, or how did it?
I think this part is lower because now it's on the walls or went out in smoke.
Do you think anything else about the water?
What did you say earlier about form?
That the water was coming out in a different form and rising at the top.
So do you think that the water evaporated faster because the water was hot? I know someone mentioned it earlier.
Yeah.
Yeah? So do we think that because it went out faster because the water was hot, does the temperature of the water, do you think it can impact our water cycle?
Yes.
How do you think?
Hot water go faster.
Hot water goes faster compared to cold water?
Yeah.
So evaporation is when if our water changes from liquid, it evaporates into gas and out of the kettle. Because when the water gets hot, the molecules inside our water bounce around and they get super duper fast, and then they go out of our kettle and turn from liquid into gas.
Wow.
So let's talk about, if we know that now, how would you say it in your own words? Is there any examples in real life, maybe other than our walk, that we can relate, think to? Louisa?
Sometimes when I take a shower, the mirror looks like that.
Mm-hmm. Do you take hot showers or cold showers?
Hot showers.
Hot showers, yeah. Can we think of anything else? Louisa, yeah.
When my dad cooks,
Mm-hmm.
sometimes the window in front of the oven gets foggy.
Mm-hmm.
I'm on fire.
And when
Yeah.
I boil pasta, I see the smoke.
You see the smoke go up? And these are all examples when we're using hot water or cold water.
Hot water.
Hot water. What about on our nature walk? Did we see any examples of this on our nature walk?
Maybe I saw some leaves be wet sometimes.
Mm-hmm.
Oh, the puddles, they got lower.
The water was less when we saw them in the puddles.
Yeah.
Some puddles were big and some were small. So maybe they all started the same and then they all went different sizes.
So yeah, so when if the puddles get smaller, then the water is going evaporating back up into the sky, into the clouds. And then later we'll learn about another part of the water cycle that brings the water back down onto the ground.
Rain.
Rain. Do you know what the word is other than rain? It starts with a P.
Precipitation.
Yeah, precipitation. What a smart cookie you are. So after talking about what we saw, knowing what evaporation is now, do you think you could put evaporation into your own words? How would you describe evaporation in your own words? I'll give you a minute to think about it. Louisa.
Are we allowed to converse first?
Converse.
Maybe it's when it gets super hot, it changes form.
When water gets hot, the molecules go
Molecules bounce around.
goes into a different form, i.e.
Air.
gas.
We submit that answer.
That's your answer? Okay.
Yeah.
So, do we have enough information now to know what evaporation is? What do we know about evaporation now?
We now know that when water gets hot, the molecules bounce around and release in a different form like gas.
So the water gets hot, the molecules bounce around, and it turns into
A different form like gas.
like gas.
No, go ahead, Miss Gwen.
You don't like my answer?
No, I like your answer.
Were you gonna add anything?
I was gonna say, but you said evaporation happens outside even with the cold water. It just happens more when it's hot.
Yeah. It can happen hot. That was gonna be what I was gonna say actually. It was gonna be, is it just with hot water or can it be cold water too?
Both.
It can be cold water, but does it happen more with hot water or cold water?
Hot.
Hot water. It happens more with hot water. All right. So now I think what we can do is we can turn over to our model and then write what evaporation is in our own words on our model. So we remember it.
All by yourselves.
All by ourselves, or you can turn and talk to a friend.